Disaccharides. Disaccharides are sugars derived from two monosaccharides by forming a glycosidic linkage between the two monosaccharides. As we've seen here, two glucose molecules form the glycosidic linkage between carbon number 1 of one glucose molecule and carbon number 4 of the other glucose molecule to generate a disaccharide called maltose. Examples of disaccharides are sucrose, cellulose, lactose, and maltose. Sucrose is simply a table sugar. It's made of one glucose molecule and one fructose molecule. So as we've seen here, the 5-member ring shown in red is a fructose molecule, and the 6-member ring shown in blue is a glucose molecule. A glycosidic linkage forms between the two anomeric carbons of both monosaccharides to generate a sucrose molecule. Connecting two anomeric carbons generate two acetal linkages. So as we've seen here, there's one acetal linkage in here because carbon is attached to two OR group, and there is another acetal linkage in here because the carbon is attached to another OR groups. Maltose and cellulose, they are composed of two glucose molecules. Instead of connecting their anomeric carbons, maltose and cellulose are formed by glycosidic linkage between carbon number 1 of one glucose molecule and carbon number 4 of the other glucose molecule. Also, they form only one acetal linkage and one hemiacetal linkage. So if you want to show it in here, we have one acetal linkage because the carbon is attached to two OR group, and we have one hemiacetal linkage because the carbon is attached to one OR group and one OH group. There is a difference between maltose and cellulose because in their stereochemistry, simply maltose is alpha 1 for glycosidic linkage because this bond is pointing downward, and cellulose is beta 1 for glycosidic linkage because this bond is forming upward. Lactose is simply a milk sugar. It's very similar to cellulose and maltose, but it is made of one galactose molecule and one glucose molecule. So the galactose is shown in blue, and then the glucose is shown in red. Hydrolysis of disaccharides is a reaction involving breaking of the glycosidic bond using water molecule. Acidic hydrolysis of the disaccharides generates two monosaccharides. Here is the detailed mechanism of disaccharide hydrolysis in acidic condition. So the first step is that this oxygen will attack the hydrogen of the hydronium ion, and this bond donates its electron to oxygen. The next step is that we will form a protonated oxygen in here. So as we show it, this is a protonated oxygen, and that oxygen will become positively charged. The next step is breaking our glycosidic bond from here. So this bond will donate its electrons to the oxygen, and we generate two monosaccharides. So one monosaccharide that is here has already formed an OH group, an OH bond on carbon number 4. And the other monosaccharide is not completely finished because after the glycosidic linkage broke, we formed a positive charge on carbon number 1. And then due to resonance, this oxygen donated its lone pair to this bond, so it has formed a double bond between this oxygen and carbon number 1. So because this mechanism is happening in water, a water molecule will attack carbon number 1, and then the double bond donates its pi electrons to the oxygen. And so next step is that we will form an OH2 plus on carbon number 1. So simply another water molecule comes and attacks this hydrogen. The bond will donate its electrons to oxygen, and we are finished with two monosaccharides. So at the beginning, we started with a disaccharide. We broke the glycosidic linkage, and we finished with two monosaccharides and a hydronium ion.